One funny story is, well, it's not really funny that Miss Cece and I were still here working last night at 8 o'clock. But the funny thing is I couldn't, something was happening with the Wi-Fi. I was making a video for my calculus class. And I was checking it, I was ready to go home. I had loaded it and it wouldn't upload. And the link wasn't working. I thought, I cannot do this one again. And they really needed it to study for the test. And she was creating papers. So I opened it on this computer, it wasn't working. I opened it on the other computer, it wasn't working. And so then we sat down, we were talking to each other, and all of a sudden they both started working. So there were 3 Miss Lazaris talking in the room at one time. Maybe your worst nightmare, I don't know.
It was your dream come true.
It was all of a sudden just surround sound. Grace has a Becky World story.
Okay.
This one's awesome.
So I had a Becky World moment that I told Mrs. Sarah about it, and then she told me something that happened to her that had to do with what happened to me. So we double Becky World.
Double.
Okay, it's a double thing. I told her my story.
But that's already happened with Amelia before. So go ahead.
So basically, I was talking to Kate Nicole, and we were talking about Halloween costumes, and then Katie was looking at different pictures. She was like, "Oh, Mario and Luigi," and I was like, "Haha, me and my friend Kendall were Mario and Luigi in 6th grade." And so we were just talking about how I was trying to find a picture to show her on my house, and I couldn't find it. And then later that day, I got a text from my friend Kendall, who is my friend from middle school, and she sent me the picture of us, and she said she was like, "Oh my gosh, look how much taller you were than me in 6th grade," and she just happened to send me that picture. And she could have chosen any picture from 6th grade, and I was really looking for that picture. So then I came to talk to Mrs. Zeri about it. And then Mrs. Zeri told me that she made a reference to Super Mario in her class that day.
Yeah, I had just talked about Mario. But anyway, so
That was it all started with my name.
Alright, it's weird looking.
it's a real place. I'm not sure what we're supposed to do with it. Okay. So anyway, it needs to be a series, like a sitcom. Anyway, another big thing, and you really need to listen to this. Thank you. When I tell you this, you're probably not going to like it at first. And it will be something that you come to adore. And that you'll even ask for more. And I'm just going to tell you, at first you're not going to really like it. But you'll learn to like it. So just trust me on this. I've done it every year until last year, until about November, and I'm just teaching my honors pre-cal class, and I thought, I'm not going to do that anymore. Maybe it's not worthwhile, this thing I'm about to tell you about, to make sure that people know their trig really good. In November, December, I was like, y'all know this stuff. And I realized it's just probably because I wasn't doing what I had been doing before, so I instituted it again, and they liked it so much, and they also went fast forward in their trig knowledge to where our goal is, when you get into calculus, I don't stop, none of us do that teach calculus I won't even stop for it in spring of this year. If I see tan of 7 pi over 4, you should know it's -1, just like 7 plus 5 is 12. If I say the sine of 90 degrees, you automatically know it's 1. I can just spout them all, and obviously I should be able to do it, but so should you. That's what we're learning now. Like, you may have sat there going, how will I ever learn what 9 times 6 is? But you eventually have these time tests, and you memorize it and make you better at it. So that's what we're going to have. We're going to have time tests. Let me tell you how it's going to work. I told you you wouldn't like it. The looks on your faces. Just it makes everybody, my skin crawl, leave the word. But some people like them. Anyway, I was just under it. So, this is what you're going to do, and you will be rulers of the trigonometry world. And we will have at least 3 practice ones before they ever count. So you'll actually know, in class, I'll go, this is practice. Some of you will make 100 right away, and you'll go, oh, please count it. I'll go, no, this is practice. And then it'll be all quick answer, off memo page material, like sine of 30 degrees, you write 1/2 kind of thing, okay? You'll have 3 minutes to answer 10 problems. You just answered 15 problems in a very short amount of time. You'll be able to spend some of that 3 minutes writing your charts down if you want to. Some of y'all will graduate from that. Some of you will always want that kind of crutch on your paper. And I'll actually model this for you. I'll set my watch for 3 minutes today or next class, and I'll real calmly, obviously I should be able to work the problems, but I'll work them like you're doing it. I'll talk you through it. I'll go sine of 120, oh, it's in the second quadrant. It's a 60-degree angle. Let me look it up in my chart that I took time to write during my few minutes, and I'll be like that about it. I won't be trying to show off or anything, okay? So at first, you might miss 2 and make it 80, and since they count for a test grade, you'll be all distraught. But then after a while, all of my students in honors pre-calc, maybe not all of them, but the vast majority, even though I still give you 3 minutes, you're sitting around after 1 minute going, but I guarantee you 3 minutes, so we'll all just sit here and stare at each other, okay? You'll get better at it. Your safety net is I'll give you at least 8 this semester, probably a lot more. But here's the cool thing, I'll average your best 5 for a test grade. So you just get to drop all your lowest ones.
Oh.
And some of y'all will make, like, the first 7, you'll make 5 100s and you'll know you've got it done. I've always found I have the caliber of student, though, that continues to take them because you know it's now going to make you sharper. The pressure's off, but you still, they kind of get fun at that point. But you also want to continue to be really good at it as your memo page and trigonometry builds, okay?
So like your main goal is like 5 new grades to average?
I'll average your best 5. Average it. Most everybody in my class, like, it's kind of a win-win. It's win for me that I know, you're trig really fast, like you're, the best in the game. But it also, most people end up with 100 test grade to average in with their other tests. And you can just keep a running total of it and know what's happening to you. I'm sorry. Things you can't do. You can come and practice with me. I would love that. I can send you quizzes to practice at home. You can time yourself. I'll give you places on topics that you can practice, okay? What you can't do, I realized that this would happen years ago. People would come by to practice and I'd give them a quiz and time them and then go over. If they made 100, they would want me to count it. We can't do that. I'm not going to start giving them outside of class time because that gets crazy. People will take 900 of them or whatever. And it sort of defeats the purpose. All right, questions, Lindsay?
So all of them count for 1 test grade?
Yeah, I averaged your best 5. So yeah, 190, 100, 100, 100. I think that's a 98 test average. And if you make 20s and 80s and 30s on the other ones, then just drop those. So I looked and count your best 5. If you're absent, it's just up to you. You may want to just continue on and see what your 5 are. But I put a little box in my grade book. I don't put a row if you're absent. Just put a little box. And that means if you want to make it up right away, that's fine. Or if later on you were like, oh, I don't have enough, I want to go back and make up that quiz, I'll even have a place to where I know pretty much what was on the memo page at that time, so it'll be fair. Okay? So like if I was going to give you one today, it would only be on things like, what's 1 over sine? 1 over sine of x. Cosecant x. What letters, y over x gives you what word? Yeah, you'll practice these, tan x. So it'll be things that you should know right now. I would not have put radians on it today if I was giving you one, because we're just not good at that yet. So I give you time to master the material. So I think you're right. I'm just telling you that's coming. You don't have to worry about it for a while. We'll have some practice quizzes. If not today, we'll start practice quizzes on Friday, to where the first part of class while I'm setting up, I'll have something up on the screen, or probably I'll pass them out to you, and because you'll want to look at them. Okay, questions, Rebecca?
Are they going to be like announced, or is it going to be?
Always announced. Oh, good point. Because we'll also have other quizzes. We'll have like regular quizzes that go on the quiz column on my grade book, and I'll make it clear. I'll go. It'll be called memo quiz. So if you're reading your assignments, it could very well say page 85, do this memo quiz, and then under that it could also say quiz on something new. So we might have a 3-minute memo quiz, hand that in for me to grade, and then I could give you a regular quiz. Okay? Good question. But girls, I won't give it to you if I don't announce it, and you can call me out on that. Sometimes I thought I typed it, I could check my assignments, and I didn't, so then I won't give you one. It'll always be announced, okay? All right, so, toward the end of the semester too, what they talked me into, and I don't mind because I just want you to be good at trig, that's my goal, is some students are really, the whole class really wanted me to double up if we had time in class, to take maybe one at the beginning and one at the end, just because the more you get, the more cushion you have to get your best 5. So we'll see how that goes. I'm not promising that, but that's a possibility also, if it looks like we're getting bogged down and stuff. Okay, now, let's talk about radians. So I'm going to go over this again and have your memo page out. This is, I don't think I'm going to show the video again, but I'm going to kind of draw it on here, where if y'all remember how the thing picked up the radius of the circle, and right about here was 1 radian. You absolutely see where the name came from. You may not know where a logarithm or asymptote came from, but radian's really obvious. They're counting by the radius of that circle. So watch what happens if I have concentric circles. If I could draw. Here's the radius of that circle, and if I wrapped it around, do you see how it would still be a degree has no dimension? Do y'all see it's not like inches? So if I say turn 60 degrees, you still have to know how far I want you to go. I might want you to go 1 mile or 7 miles in that direction. Okay, so that's a really cool thing for later on. Degrees and radians are dimensionless. You don't know how big they are, but they're very consistent. Okay. So if you think about that, you really know that from degrees and radians, because this is 90 degrees no matter where I am, no matter how big the radius is, which again is why I'm not a huge fan of the unit circle, because I noticed when I taught it, students would get stuck on the fact the radius was 1. You may wonder why people use a unit circle. I may have spoken about it before, and it's because in the unit circle, if you make the radius 1, because you certainly should wonder what's the big deal there. If you make the radius 1, the coordinates of like 30 degrees, the ratios come out exactly like they do in your charts. That's the moment in time they're 1/2 and square root of 3/2. But I hope you realize if the radius was 15, they would reduce to those same numbers, 1/2 and square root of 3/2. It's all a ratio. If the circle gets bigger, the x and y coordinates get bigger proportionally, which you certainly know from your special right triangles. Okay? Elena?
So the radian is the same, like no matter the size of the radius?
Yes. It's the same. Like if I say pi over 2, you don't even have to know how big the circle is. You know you're right here.
Wow.
Okay? All right, so that's an interesting concept. 1 radian lands at a kind of unfortunate place as for us, but so do centimeters. I have this nice 1 inch, and I learned that it's 2.54 centimeters, and that's probably not even exact. If I wanted to be really meticulous, I'm imagining that decimal goes out further. Okay? So the metric system, when we convert to the English system, is inconvenient. The radian system's better. When you convert to degrees, it sort of doesn't land where we would like it to. But oh my gosh, it's super cool. Still kind of freaks me out that it goes 1, 2, 3, and then a little bit more and lands right on what we call this irrational number. A lot of the great mathematicians were philosophers. I don't know if y'all know that. Great thinkers of our time. They looked and delved into, you know how much Isaac Newton looked at. You hear of Archimedes and Aristotle. Some of you may be familiar with Pascal. A lot of them are great philosophers. And it's sort of interesting, a lot of times in this class we'll talk about some philosophy. It's kind of interesting that we call them irrational numbers, because those seem to be the ones that keep popping up that make sense in the real world. Like to our human minds, we go 1, 2, 3, 4. But when things really start happening, we have numbers like the golden ratio, 1.618, that is just naturally pleasing to us in this rectangular form. I think you've heard of the golden ratio. Even our bodies are made according to the golden ratio of like our arm span. I don't know if y'all have seen all of that before. But the ratio is like some irrational number. When they look at the growth of like things in nature and they want to know the base for nature's E, 2.718, that you may have heard of before. But it's irrational. It goes on and on. But I'm kind of thinking maybe we just don't know everything, because it seems like all the important numbers, we call those irrational. Our numbers might be irrational. It really doesn't happen very often that you go 1, 2, 3, 4. So anyway, that's interesting. We'll talk about imaginary numbers another day. But in any event, this is 1 radian. As I wrap my radius around again, y'all all saw this go 2 and then 3. And so how many radians is halfway around?
3.4.
all right, which is a whole lot more convenient to call it pi. And so all the way around is 2 pi. All right, so let's go to another slide of his. So let's just do radians and not put degrees on. Okay.
You have to see him in
So ugly.
No, that's bad photo.
And you think what's the other one with all
Girls.
Timothy Fallon. No, he's gorgeous.
Oh, no,
You're
he's
kidding.
No,
he's
not. You're just a good photo.
Lily?
I'm sorry.
Okay. It's okay. We're doing radians, okay? We're not voting on his attractiveness. All right, if this is pi, which is really super cool, I'm going to divide it into 3 equal parts. Okay? You don't have to write this down. I would love for you just for your viewing pleasure. Okay? So this is 1/3 of pi, and this is 2/3 of pi. Okay? All right, might as well keep going. And y'all saw me count by this real fast at the end of the other class. This is 1 pi over 3, but I just write it as pi over 3. This is quite literally 2 pi over 3s as I go like that. And then 3 pi over 3 when I get to right here. And so what's this one? 4 pi over 3. Do y'all notice I haven't even drawn a circle? It doesn't matter how big the radius is. I could draw a little circle or a big circle or whatever, okay? 5 pi over 3s. And so I've counted 1, 2, 3, 4, 5. How many pi over 3s is this? 6 pi over 3s. All right, so we're going to call that obviously 2 pi. Your conversion's real easy. Pi is 180 degrees and 2 pi is 360 degrees. You'll most likely be using a lot pi and 180. All of you, some of you, a few of you are not converting to degrees and you already have an understanding of radians. I'll give you maybe a better understanding of that today, or you can pipe in and say what you do. What was I going to say? We cannot, like, in next week even, be saying the sine of 2 pi over 3, and you go off to the side and multiply it by 180 over pi, and you reduce, and you get 120, and then you look at your charts, and you find the sine of 120. We're going to be 5 problems down the road, because we're going to be fluent in radians, and we're not going to convert to degrees, okay? You might go, well, I could always do that. Well, you could, but you won't keep up. So
How do you get to that point?
today you will. So just keep watching. I'll teach you lots of cool stuff, okay? Now, I'm going to divide it into 6 equal parts. 1, 2, 3, 4, 5, 6. So this is one of my pi over 6s. Y'all saw in a real speedy fashion the other day, that's 2 pi over 6s, which is really nice, because that's pi over 3. This one's 3 pi over 6, but what are we already a little bit used to calling that one? Pi over 2. All right, and then 4 pi over 6. 5 pi over 6. Next one, 6 pi over 6. And then let's draw some more. This one's 7 pi over 6. The next one is 8 pi over 6. The next one is 9 pi over 6, but what did we call that? Sorry, 9 pi over 6, we call that reduces to 3 pi over 2. And then 10 pi over 6 is 5 pi over 3. And then this is 11 pi over 6. Now let's pause for a minute. Those are our 30s and 60s. All of the red ones, do you notice, make a 30-degree bow tie? Well, what's great about that is I don't even have to subtract anything from 180 or 260. I don't want to go to degrees. 11 pi over 6, I know automatically I'm counting by those little pi over 6s. I can just look at the radian measure and know if it's an exact form. I can tell you it's a 30-degree reference angle. Do y'all see what I mean? Okay. Now, what did you notice in blue about everything in blue gives you a what degree reference angle? 60. And this should make sense on all fronts. Pi, you're now becoming fluent, okay, where you, I'm not fluent in any language besides English, that's Latin. You know, if I was fluent in a language, like, who knows German? Okay, I picked the wrong one. Who knows French?
All
Okay,
of it.
What's paper in French? Oh, well, I can do that. But you probably think of this, if I held it up, you probably think of both words simultaneously. You don't even know if you're fluent, maybe which one you think of first, okay? So when I'm looking at that, I don't even know what I'm thinking of because I've done it for so long and you haven't, but you'll get good at this. I think of pi is 180, just like I know both words for paper now, okay? So, I did take French 1 year, my senior year, I kind of added in just because I heard the teacher wasn't very good at making names, so I didn't even know that. Okay, so anyway, pi is 180 degrees divided by 3, and I've counted out 5 of them. Do y'all see that that would be 5 of my, I would have landed at a 60-degree angle. Hopefully that makes sense. Isabel?
When I was doing the homework, I was multiplying it by 180 with pi first. But
Which we're going to stop doing today.
yeah, so could I just like look at all students, same like all students take calculus, but then look at
You'll know your reference angle.
Okay.
Yeah. And then at some point, you and I don't even know if you're thinking in degrees or radians. You just sort of have it. So which is the point, okay? Now let's divide this into half. Well, if that was pi over 2, what does it make this? Hello?
Pi over 4.
Thank you. Thank you, Katie. I expected a bunch of people to answer pi over 4, okay? And so this is 1 pi over 4 that goes all the way halfway through. This is 2 pi over 4. This one is 3 pi over 4. And the next one is 4 pi over 4. Obviously, I won't do this again, okay? I need to do it twice, then we'll be done with it. This one is, and because that'd be horrible if you came in here every day and I did this. This one squeezed in here. If you think about that, it should be 15 degrees on either side of these two. Because aren't those 30 degrees apart? Okay, so if they're 30 degrees apart, that makes sense for it to be 30, 45, 60. I haven't really spoken that that's 45 today, but I hope you realize that because this is 90 and half of that's 45. Or if you take 180 and divide it by 4, you get 45-degree increments. All right, so 3 pi over 4, and this one was 4 pi over 4. So this one is 5 pi over 4. There's crazy seniors outside. This one's 6 pi over 4, 7 pi over 4, and we end with 8 pi over 4. So all of these green ones make a 45-degree bow tie, okay? And I think I showed you a unit circle. It's on my topics page. You can see it. You'll see other students that probably walk around with the unit circle with the points written out here, and they look at it that way. They see they're like this quadrant, and they learn it sort of the same way. They may look at it a lot, and they realize, oh wait, every time I look in this quadrant, I've got a positive and a negative. Every time you're in this quadrant, so they're seeing the same thing, but I find that the charts are easier. So I don't do that, but I need to show it to you because a whole lot of people still use the unit circle. When you go to college, just don't have a fight about it. People will go, well, let's use the unit circle. Say okay. I mean, they're not going to know what you're doing. So don't fight over if the charts or the unit circle's better, okay? People in my class will do different things. But I'm going to land in one place so that I'm being consistent. Okay, now let's move ahead. Okay, so how would I figure out really fast the sign of, oh, by the way, sorry, I just remembered this. Another reason that I found once I learned the charts that I wasn't a fan of the unit circle is this only goes in that direction and it stops at 2 pi. But y'all have already seen me ask you things like the sign of negative 120 and the sign of 390 and things like that. So the chart method, you don't care how far it goes. Here, you're just sort of having to figure out where negative 2 pi would be. But if you're not looking at this, you're thinking more realistically of your special triangles, okay? By the way, these are all of the common angles, 30, 45s, and 60s translated into radians, okay? A radian doesn't have to have a pi in it. Y'all already know I can have 1 radian. I could have 4.8 radians, okay? 1.4 radians would be about right here, because this is about 1.5 radians. So at some point you'll get a sense of where all of those are. Let's worry about that later. All right, so how will I know, like the sign of, let's just do 5 pi over 3 without converting, okay? Because a lot of you converted. Some of you typed it in your calculator. Some of you converted and then typed it in your calculator. Rebecca?
I would take, I know it's over 3, so that means it's 60 degree angle, which means that it's 1/2. Wait, no, sorry, that thing cosine. Square root of 3 over 2. And then 5, I would take 5, and then I know, like, it's more than 1, so it's beneath the x-axis. And I also know it's, like, further than the x-axis, and it's in the 4th quadrant, which is chemistry. I'm sorry, calculus.
That's fine. All students take chemistry is good?
So it's negative.
Okay, so, did y'all run around saying that instead of all students
Yeah,
take
I say
calculus?
chemistry, just my it works better for me.
Okay,
It just more like a sad sentence.
that's fine, that's good. Okay, what she said is really, how, it's very similar, if not exactly the same to how I do it. Like I said, I used to teach the unit circle, and I noticed that some people were faster doing things instead of finding it everywhere and counting around. And I had a student actually that, as my students were at the board struggling, like, how will I know where this is? A kid named Wesley Ingram, he's a minister today, he doesn't do trigonometry as far as I know, but Wesley Ingram raised his hand and goes, can I show you how I do it? I listened to her for a while going, at first I was going to cut him off like, oh no. But the more I listen, the more I'm like, oh, that's great. I always teach it that way. Is pretty much what Rebecca's doing. You can always find where you are really quickly. She automatically knows that pi over 3 is a 60-degree reference angle. Remember, that's pi divided up into 3 equal parts. Somebody was talking with me, 180 divided by 3, if I'm thinking about both of them. That's pi, or 180 degrees, divided by 3. You'll get used to knowing those are 60s. Okay, they're bigger, aren't they? Pi over, kind of feels funny that they're not 30s, but pi over 3s are bigger than pi over 6s, aren't they? Okay, so you know right automatically. Now you'll get better at knowing, like, oh, you kind of, my brain goes to the sine of 30 is 1/2. It's the first thing in my chart. So by default, I know the sine of 60 is square root of 3 over 2. Some of you are already getting to where you don't have to look at your chart so much. So let me move past that. This is what Wesley did that I would recommend. He thinks, just like he said, I do it just like I do it in degrees. If I put 160 and ask you to draw it really fast, every brain in here probably thinks about it's just before 180. Don't we? We've already talked about, we tend to think of these two. If I put 310 on the board, your brain thinks 360. And you go all the way around like this, and then you figure out how far away you are. So we're always naturally thinking of these. If I say 220, you go past 180 in your brain. Aren't these your reference points? By the way, if they're not, they have to be. I don't count from 90 and 270. You'll get the wrong reference angle, okay? And then you'll get the wrong answer. All right, so what Wesley did, that I do now myself, is he said, let's just do the same thing. So what he did is he knows this is pi and 2 pi, okay? And similar to what Rebecca said, the reference angles are going to be over here or over here, away with my butterfly or bow tie from pi or 2 pi. Do y'all see that? Okay, so if Rebecca and I are thinking in pi over 3s, and we're thinking of this as 6 pi over 3, and this one is 3 pi over 3. In our head, probably. Okay? Do y'all see if I'm thinking in 4s, what would my brain automatically think of 2 pi? 8 pi over 4. Do you see how I could quickly convert it to a common denominator? So now it's worth 5 pi over 3.
Close to 2 pi.
We know that it didn't quite make it there, right? That's right before 6 pi over 3. So I know 5 pi over 3 is in the 4th quadrant. And all students apparently take chemistry. And cosine's positive, so therefore sine is negative. Don't ever put one down without figuring out your sign. All right, so let's do the cosine of 11 pi over 4, because I haven't fully explained this. Thank you. It's kind of creepy. Okay. I don't know how I did that. That's kind of hard to do. All right, 11 pi over 4, we automatically know it's a 45-degree angle, which is root 2 over 2 with sine and cosine. So I at least got that much right, and I give partial credit. So do you see I already got my ratio, okay? I know my reference angle is going to be 1 of the pi over 4s. And so what Wesley did, if it's, sorry, I got to pause and really explain it a little bit better. 5 pi over 3, you're going to think of the closest multiple of 3 that you can get to 5. And you'll get it right every time. It can be over or under, but it's got to be the closest multiple of 3 that you can get to 5. Wouldn't that be 6? All right, which you automatically know in your head puts you at 2 pi. Is this before 2 pi or after 2 pi? So do you know you're in the 4th quadrant? Stay with me, I'll get you to do this. Nicole, think of the closest multiple of 4 you can get to 11. A 4 won't go into 11, but what would it go into? 12. So our brains think of, oh, I almost got to 12 pi over 4. What's 12 pi over 4? 3 pi. Where do you think that is? This is pi, 2 pi, 3 pi. I didn't quite make it there, so what quadrant am I in? The second. It's root 2 over 2. All students, that one's going to be negative. I'm going to do a few more before I take questions, so please don't forget your question, okay? Write it down if you're afraid I'm not going to answer it or remember. All right, now, so let's find the tangent of, let's say, 7 pi over 6. What's the closest multiple of 6 you can get to 7?
6.
You can go over or under, but you've got to get as close as you can, okay? Where's 6 pi over 6? It's over here, so where's 7 pi over 6? You automatically know it's in the 3rd quadrant. So you don't have to memorize all those things. Do y'all see what I mean? You don't have to memorize them. So then you know you've got a 30-degree angle. I know y'all are still working on this stuff. Root 3 over 3. All students take, it's positive. And I'm not even going to degrees, but I probably am thinking about degrees without knowing it, okay? Let's do the sine of negative 15 pi over 4, which now my unit circle's out the window, okay? So what's the closest multiple of 4 that you can get to 15? 16. You've got to keep in mind you're going this way, right?
Yeah.
But you automatically, I think, Elena, you knew it was going to land over here.
Yeah.
All the evens land here. Pietra, it looked like you knew that too when we got the odds. Pi, 3 pi, I'm sorry, I'm pointing the wrong way for y'all. Pi, 3 pi, 5 pi, they land over there. Coterminal, 0, 2 pi, 4 pi. A full circle is going to land on an even one. Okay, so I don't want to lose you here. We're going negative 16 pi over 4. Oh, I'm sorry, I didn't finish that. That's negative 4 pi. So you know you're going to land over here. It's negative 15 pi over 4. Did you make it?
No.
So you're in what quadrant? The first quadrant where everything's positive. The sine of 45-degree angles is root 2 over 2. I'm in the first quadrant, okay? And I know that I've rotated this way. So I'm going this way toward negative 4 pi, okay? So that was particularly like you had to think about some more. All right, let's do, let me let you do, well, let's do one more together and then I'll give you some to try. So let's say the cosine, we're going to do 2 more. Cosine of 7 pi over 6. It's really close to what pi over 6? 6 pi over 6. What quadrant is this in? Awesome. You're really good at that, okay? So in your head, you're thinking, oh, 7 pi over 6 is really close to pi, right? But it went past it, didn't it?
Yeah.
So it's in the 3rd quadrant where cosine's negative square root of 3 over 2.
Wait, it's in the 3rd quadrant or the yeah? Because wait. Oh, never mind.
You okay, Nicole? All right. All right, let me give you one to try. This one's a little bit tricky. So because you've got to think of a lot more things, or one more thing, not a lot. Okay? I just quietly do that. Try it.
Like quarters. Like think of the whole thing.
Okay, we'll do that your way.
Okay.
So do it your way. See how fast you do. Okay, got it. All right, what's your answer?
2 root 3.
It would be 2 root 3 over 3. So I'd stay with what you're doing. Okay. You could have 2 over square root of 3 or 2 root 3 over 3 if you're in Delta Math. Okay? So why don't you tell us what you're doing, Isabel?
Okay, so I think of like the whole like plane as a like as every piece has a quarter. So then I know that once you get to like
So you're doing a fractional thing too.
yeah,
Okay. So you're 2/3.
because I know 2/3 would be like less than half. So then it would have to be in the first quadrant because
Oh wait, this is in the second quadrant.
no, that's what I meant. Yeah, it would have to be in the second quadrant because it's more than half, and then if you got to the third quadrant, it would have to be more than 1.
So it's the same thing. You're still doing like a fractional thing. I think you're fine. As long as you knew this was in, because it would also have been positive in the first quadrant, so I don't.
No, but it's more than.
You're okay?
Yeah.
All right. Did some of y'all think of 3 pi over 3? Which is pi. So you didn't make it. So you're in the second quadrant. You had to do the little bit of extra work to make sure you found sign and put the sign to it and flip it over. Okay, Bella?
That should be
3. I think that's the second time I haven't written a 3 when or I don't know what I'm doing. Thank you so much. But she said it. She said 2 root 3. I don't care. Doesn't matter. Okay, Elena, did you just have a question, Zoe?
So,
Okay.
it doesn't matter if you go like under, right? Like maybe 11 over 4, like it's more than 8. So you know it's more than double, so it's just...
It depends. I think you've got to find your way. Like, I would think of that as 12 pi over 4, which is 3 pi.
Yeah.
And I didn't make it there, so I know I'm shy. I'm
Yeah.
away
So
from
you
it.
just like make that like in your head like 3 pi over 4.
I know it's right here. I'm not sure if we're saying the same thing. Oh, I'm sorry. That's wrong. Hey, girls, stay quiet because we have a lot to do in the next few minutes. It's right. It's in the second quadrant.
Yeah, that's what I meant.
Because this is 1 pi, 2 pi, 3 pi, and you didn't make it. If it was 13 pi over 4, where would it have been? Third quadrant. Girls, look. 13 pi over 4. What quadrant is that in? A couple of you have already answered. Third quadrant. It's really close to 12 pi over 4. And it went past it. Do you see how it went past your common denominator? All right, let's do a couple more. Or I tell you what, get out worksheet 4 and your memo page. All right, on your memo page.
He's so hot.
Guys, you're just figuring it out.
One more. Maybe this is my last
Okay, are y'all finished? Thank you. For a little while anyway. Hello. All right, that's okay. She can think that. Okay. In your chart, your degrees are 3, 4, 5, 6. Okay? In radians, though, these two numbers switch. this one's pi over 6, and this one's pi over 3, and this one's pi over 4. You should not struggle with that, though. If you all of a sudden panic and go, oh my gosh, I gotta write these correctly, pi over 6 is the smaller fraction, right? I mean, you know, I've explained it to you. I'm not just teaching it to you. You ought to be able to get your way out of it. Now you can look at these for your reference angles, which is what Rebecca and some people are doing in their head or looking at their charts, okay? So if you have anything pi over 4, you at least know your reference angle. You got your numbers, sine, cosine, and tangent. You got to figure out what quadrant it's in, okay? Who can tell me what quadrant 21 pi over 4 is in?
The first, second. No, the second. Third. Yes, the third.
All right, let's write it down. It's the third, okay? 21 pi over 4 is close to 20 pi over 4. 5 pi. Good. 5 pi's over there. And did you make it there?
Yeah.
So that's fast. Third quadrant. Then I have to put a word in front of it and could go on from there, okay? All right, now let's go to this.
Hey.
Sorry, it's gone. Let me close it. There. All right. So sorry. That's horrible. Okay. Y'all ready? Mr. Hell and I have had a competition to see who could do it the fastest. And I beat him, and Mike could beat me now, but I'll never play him again because I beat him that time, and I can always go, I beat him that time. I think Anne-Marie Burke, actually, when she was playing it, I think she got on the leaderboard wherever that is. I think she did it in like 11 seconds. All right, you're just going to help me right now. But did y'all see it under topics? Let me show you where it was. If you want to try it, practicing your angles, okay? So, here we go. 5 pi over 3. First, tell me what quadrant to go to. 5 pi over 3. Third, and it's 60 degrees away. Y'all okay with that? Oh, I'm sorry. Y'all said, I knew where it was. I'm sorry. Let's keep going. I'm sorry.
It's the first one.
Good. Whoa. Great. Wow. Wow. Y'all are awesome. Which one?
It's the last one. No.
Whoa, it was over 3, wasn't it? Because it's like 60. Sorry. Close to 8 pi over 4. No, 5 pi over 6 is close to 6 pi over 6. Okay. All right. If you miss, just so you know what happens if you miss, it goes like this. It has a little bling if you miss, okay? All right, so that's really fun. All right, now, let me look at someone's memo page and make sure I have everything on there. Have you filled in all your radian columns? Yes. Oh, but you need to. So is everything filled in right now? Okay. Your homework, is to do worksheet 4. Try to do it now. I think it's worksheet 4 radians. Okay. Do worksheet 4 and try to do it without converting, but you probably all do some of both, okay? But don't actually sit down and convert. Try to think in radians. So worksheet 4 is your homework, and we'll have a practice quiz on Friday. So don't worry about it. I'll just show you what it's like.
On
Okay?
Tuesday.
Oh, I'll get to your account. Don't get wrong. Hey girls, wait, come out. Sit down. I have 1 more minute. I forgot about the forever away before I see you in a week. So check assignments. I may also give you something else to do out of the book. Okay? Bye.
Bye.